All right, we are good. So chapter 2.5, transformations of functions. Now this is a huge section. There's going to be lots of word problems from this. We need to get a blank pen. Okay, so what we are doing here is, overall I'm just going to give you an idea what we are doing, what is transformation of functions means. We are going to work with our basic functions, basic library of functions. At this point, we have talked about all the library of functions many times, right? So, again, I'm going to describe this. So, it's right on the side, library of functions. What's the first one? F of x equal to mx plus b, anything like this, we know how to graph, no doubt. Number 2, f of x equal to x squared, very good. You guys have to tell me all this, I'm not going to write any of this. Number 3, x cubed, f of x is equal to x cubed, cubic function. You know how to graph this with at least 5 ordered pairs labeled. Number 4, China. Very good. Absolute value of x, right? Absolute value of x. Number 5, Elizabeth.
The square root of it.
F of x is equal to square root of x, right? Very good. Bailey, another one?
G of x equals,
F of x equal
1 over x.
and then can you have like the bracket, and then x plus 3.
brackets x.
So like the one we just did in today. So it's like the bracket, so then it has
Yeah, but that is not part of the library. It's that's piecewise defined functions,
Yeah.
right? So that can come with some of these. That's not part of the library of functions. We use library of functions to graph piecewise defined function, right? So what's the part of library of functions? We did another one here.
F of x equals 1 over x.
Very good. This is called the rational function. 1 over x, we know how to graph this, right? Yeah, so you guys, the other ones, at least these 6. 3 or 4, this is also a huge test question. You will graph the same thing. We have done this many times, okay? Okay, so now we use all these, we are going to use all these. We are going to use all these, use this to graph something like this. To graph f of x is equal to x squared plus 2, something like this. Or f of x is equal to x plus 2 squared. F of x is equal to x minus 2 squared, like this. Okay, so this is what this is called. So this is the one that now we need to graph this. What do we need to do? Need to graph this. This is your task. Not we already know to graph this, but we need to graph this now. These are your problems, right? So our example is need to graph these. Graph these, right? Need to graph these. But how are we going to graph these? By using the transformation of these. In other words, we use x squared and transform that into this graph. Are you following that? That's what transformation means, okay? But I'm going to write, I just gave you the overall thing that we are going to do. What's our plan? What is transformation means? So we are going to use these, in this case we are going to use this graph and transform this graph to this graph. We are not going to do the like 4 things to graph this. We're just going to use that to graph this. Another example, if I write here, another example, example number 4, f of x is equal to x minus 3 to the power cube. Which one we are going to use here to graph this one? Which one you are going to use here? X cube graph. We are going to use the x cube graph and transform x cube graph to this graph. That's it. Okay? So if you don't know to graph those 6, are we in trouble here? Yes, we can do it. Now if you know another method to graph this by creating the table of ordered pairs, a lot of people do it, that's not the way you're supposed to do. You're supposed to show the transformation. Okay? Okay, so now I'm going to write some definitions here. Definition. This is in your book, page, I'll write the same thing as the book says here. Page 219. Page 219. It says vertical and horizontal shift. So we are going to do 4 transformations here. Okay? So one thing is, there's 2 things here. Together they have these 2 things here. They're talking about vertical and horizontal shift. Vertical and horizontal shifts. So there's 2 things here. So, number 1, so the definition is this, let C be a positive real number, let C be a positive real number, vertical and horizontal shift of the graph of y is equal to f of x are represented as below. Vertical and horizontal graphs. Vertical, I'm writing the same thing that the book has here. Vertical and horizontal shift actually. Shifts in the graph of y is equal to f of x, in the graph of y is equal to f of x, in the graph of this is the basic one we are going to call y is equal to f of x, are represented as follows. Okay guys, let's see what this is talking about. So don't worry about it now. But what are we going to do? We are going to carefully read until we completely understand the statements. Okay? First time you read, you don't understand, don't worry about it. We're going to try again until we get it. Right? So far, I'm sure you guys have doubts about this sentence, but that's okay. Vertical shift, C units upward. Shift. Vertical shift, C units upward. C unit upward, h of x is equal to f of x plus c. This means h of x is equal to f of x plus c. So, which one this is now general, okay, in general, okay. In general, if you are asked to graph a function called h of x, this f of x is one of the basic functions. Think of this, f of x is one of the, y is equal to f of x is one of the basic. But we already know how to graph this basic. F of x, in this case, your f of x is the basic function. H of x is something that relates to the basic function that we are going to manipulate the basic function to graph h of x. H of x is a different function that you need to graph. Are you following me? Just like I did the x squared plus 2 is h of x. But we need to graph that using which one? X squared. X squared is the f of x. Okay? So you understand the statement here, we are graphing this. So what this saying is this. When we are supposed to graph a function this manner, like f of x plus c, f of x is one of the what functions? Basic functions. This is always, you look at the basic function and c is a number of units. If you have plus c, what is it going? F of x is going what way? Upward. How many units? C many units. So all you have to do is look at f of x and move that f of x 2 units up every point. That's it. Shift. Take f of x, shift 2 units up. That's what this statement says. Everybody understand this? Very good. Okay, so this is number 1. Number 2 for this, vertical shift C unit. What's the other one? It can go upward or vertical shift means vertically. Going up, going down. We are going to transform this function, graph this function by transforming the other function that we already know. So what is it? It can go up also, it can go down. So vertically going down means the graph that we need to, the function that downward means what? H of x need to be what?
F of x minus c.
F of x minus c. This is the second case. When you see this case, we know this is a vertical what?
Shift downward.
Shift downward. It's a vertical shift. Whenever you talk about vertical shift, we have vertical shift upward and downward. So I'm going to put another example here. X squared minus 2. This is downward 2 units. This is upward 2 units. We will graph this. Okay? So without even doing the graph, you understand the definition now, right? Read the definition, understand the definition. You have an idea now. When you do the graph, you will be verifying your idea. Okay? You will be happy. You are thorough with the idea. Okay. Number 3. So we are doing the vertical. Vertical shift only 2 things. This is only the 2 things that you have to worry about. Okay. Now usually I give this as rule number 2 here, but that's okay. I'm going with the book. I do horizontal shift separately, but this your book talked about vertical and horizontal shift the same way. Okay. Okay. So now number 3 it says horizontal shift, vertical shift C unit, horizontal shift C unit to the right. Instead of vertical shift, horizontal shift C C unit to the right. How will you represent this one? C unit to the right. I'm going to, okay, this part I'm going to write here, guys, sorry. So number 3 continue here, okay? C unit to the right. What do you need to do? H of x, C unit to the right means what? This is number 3. H of x need to be, how will you write this?
F of x minus c.
How will you write this? F of
X minus c.
x minus
C.
c parentheses. That means if you see something like this, that means with a negative sign and c is inside the parentheses evaluated at f of x, right? Then the graph goes to the, your basic graph goes to the right.
Professor?
Huh?
I'm just confused, because if it's horizontal, wouldn't that go up and down, and then vertical go left and right?
No,
No? Okay.
vertical goes up and down.
Yeah, so but
Vertical goes up and down, that's what we have, vertical.
could a shift, wouldn't it just, okay.
No, vertical goes up and down. Horizontal goes
And then left and right?
left and right. This is horizontal, left and right.
Okay.
When the x is getting positive, it's going to be right.
No, x is good. This is how it's not what you don't have to know exactly why this is. Just remember this. If it's minus, it goes to right. Remember this. If it's minus, it goes to right. You will see the reason to this later on. But now you don't have to justify that. Just remember to make it easy. We are using the model. The mathematician says what? If it's minus, you move to the right. That's all you need to remember. So mathematics, the other part of it, you build up your memorization skills. You learn how to use the tools. That's it. So you don't have to worry about why now. Okay? Minus sign means, so in this one, if you look at which graph is talking about rule number 3. So this is rule number the 1, right? This is rule 2, this example, correct? What's rule 3? Which one is the example for rule 3? This one, right? Not this one. If you have this one, you take x squared and move to the right. How many units? 2 units. You guys see this? So this is rule example for rule 3. But following this, rule 3 example, right? Now, this is also rule 3 example, correct?
Yes.
This is also rule 3.
Yes.
So I gave this with, even though book has under the same, I am giving this as rule. You can take this under the same, these are rule. Okay? This is your rule. Okay, so now we need to write number 4. Number 4, I'll write here. You guys copied this, right? Okay, number 4. So part of this you can write this underneath here. So I don't have space here, so I'm going to move up here. Rule number 4. We have the same thing that I wrote on top here, right? For you guys. Continue with the same thing. Rule number 4. Horizontal C units to the left. Horizontally. It's a horizontal shift. Horizontal shift. C units to the left. C units to the left. This case, h of x need to be written as what?
F
F of x
plus c.
f of x plus
C.
c parentheses. Okay? So this is how it used to be, it has to be. So if it's c units to the left, the rule has to see as plus. Okay?
Which function are we?
Plus doesn't mean we have to move right. Okay? Okay, so now, what's rule number 4 example for this? Wasn't this rule number 4 example?
Yeah.
Yes.
So this is rule 4 example. Okay? Okay, now, let's do some. I'm going to erase this, guys. Everybody understand the definition?
Yes.
Okay, so now let's do a couple of examples, and you guys going to follow vertical shift and what? Horizontal shift. Vertical shift can go up or down. Horizontal shift can go left or right. So I'm going to erase this. I'll do this again. I'm just going to clear the board here. Okay, let's see. Okay, so example. Example number 1. Graph f of x is equal to x squared plus 2 using the transformation. I'm just going to say using the transformations of, I'm not even going to tell using what transformation. You should know that, okay? I'm just going to say not creating a table of orders here, not using how to graph quadratic functions. Using transformation means you are going to use the 4 rules that we covered. Everybody understand? Okay? Not any other way. So if you put a table of ordered pair, or if you use the vertex and x-intercept, y-intercept, do all that stuff, does it count? No. So first thing, it's really good, guys, if you can come up with graph paper for this, because you're going to do lots of moving. So here, first thing we're going to do is we are going to graph x. We know here. Now I'm not giving you. You don't see this as h of x, okay? This is your h of x, but this is just a name. You see what I mean? So your basic function is x squared. That's what. Okay. So this is what you need to graph this whole function. So we need to know how the graph are going from 0, 0, 1, 1, -1, -1, 2n, 4, 2n, -2n, 4, right? So we know the graph of this. I'm going to, this is not the graph we want. So I have it undotted. So this is exactly what you're going to do. You put it in dotted. This is not our graph we are looking at. We need to graph. We are going to use another tool to graph that. Okay? So this is called what? What is this function? You can say this is y is equal to x squared. You can write this as y, the basic one. Okay? Or you can put another name, h of x equal to x squared, doesn't matter. To make it simple, write y. Okay? That's this one. Okay, now we need to graph this function. What is this function is about? How are we going to graph this function?
It's going to vertical shift.
Vertically shift, very good. Every point, so you need to come up with these 5 points. You see these 5 points? You know exactly what these 5 points are. Vertical shift means you keep the same x coordinate and move the y coordinate. Very simple, guys. Vertical shift means use the same x coordinate and move only the y coordinate. So start from here. So now this point is going to be where? Up here. This point is. Here, this point is. This point. Vertically, you don't go throughout together with the graph. You go vertically. X is the same, only the y. So vertically up to 1, 2. This one. 1, 2. You guys see this? Now we are ready to graph this, correct? This one, when you graph, we are going to make a solid graph. So what's the rule for this function? What's the rule for this function? What is it?
Number 1.
Vertical shift?
Vertical shift.
How will you address this function?
Y equals x.
Yeah, this is f of x equal to what?
X squared.
X squared plus 2 function. This is the one that you need to graph. We use this to graph this. See, we manipulate in mathematics, we manipulate. Remember I told you guys this before? What we does in mathematics to save time, save energy, save money, we manipulate. Okay? We could have done this differently, this graph, by looking the vertex and all that. But now we don't have to do all that stuff. You don't have to do 4 different things to graph this one. Are you following me? This one can be graphed by converting, later on we are going to do, converting to the vertex form of a function. I'm going to show you guys later on that also after we do the transformation. Okay? There's 3 different ways to graph this function. But right now we are focusing on using the transformation, which is easiest. Okay? So you have to read the directions. Direction says use transformation. For me, you need to give both graphs so that I know you use the transformation. Make sense? So this one doesn't take 2 minutes for you to do. Really fast. Use this, use the transformation, show this one. On the same grid. And label both. Any questions? Okay, so let's do another one. Another one, example number 2. I'm going to say f of x, graph f of x is equal to x cubed minus 3. What do you think of this, guys? What kind of graph we are asked to graph here using the transformation, if this is transformation? What is it, Sharon? We are using y is equal x cubed, and what shift you have it in mind here? Vertical shift, up or down? Down. Very good. So you have the whole solution to this, how to do it. right? So first thing we need to look at x cube. So this something like this. See how complicated it can be to graph this. If you see this at the beginning, you don't know the strategy how to do it, right? But now without even starting to do, you know how to do it. How to use the operation, right? See, you're thinking when that's how you're supposed to think before you even start, you have your plan. So here, x cube, you already know how the x cube is graphing now. Everybody knows this, right? So x cube goes where? This here, this, 2 and 8, right? Negative 1, negative 2 and negative 8. So this is how x cube goes. Please be careful. This, when you graph this, it has to be the smooth curves. I've talked about this, okay? You don't make straight lines when you graph this. It's supposed to go like this. This graph is f of x, y is equal to x to the 3. The basic one. Now we are going to use this basic one. How many units? 3 units down. So go with all these units here. This is the 5 units. We talked about these 5 units. Each of these points go vertically down. How many? 3. So let's start with the 0 here. Go 3 down. So what's your point going to be? 2, 3. What's the point here? 0 and negative 3. What is this point going to go? 1, 2, 3. What is the x coordinate here? What's the x coordinate here?
1, negative 2.
1 and y coordinate negative 2. Right? Take this, move 3 units down. So this. Now we have to take this and move 3 units down. So this is 2 and 4, 2 and 8. Right? Move 2 keep the same, move 3 down here. What is it going to be? What is it going to be? 5, right? So it's going to be 2 is the same.
2, 3.
So it's going to be 2 and
2.
what?
2, 2.
2 and what? 5, because this move 8. 8 move down 3, vertically down 3 is going to be 5.
Okay.
And subtract 3 from 8. So that's this here. Now we go here. 3 units down. This is negative. Sorry, it's supposed to be here. This one is here. Negative 1 and 1. Negative 1 and 1. Move 3 units down, going to be what?
And 1, negative 4.
Negative 1 and negative 4. Because this one was negative 1 and negative 1. So now it's negative 1 and negative 4. And then the next one is, this is negative 2 and negative 8 is going to be negative 2 and
Negative 11.
you go down 3, negative 11. So it's coming from negative 3, negative 11, and we are going to have the same pattern. Same smooth curve. So coming from here, going this, going here, going like this. You see that? It's the same curve. because this 8 is supposed to be, I actually, when I was drawing this, it's supposed to be little this way, like this, somewhere here, the 8, okay? So it goes like this now. You guys see that?
Yeah.
So this one is little harder because the curve is little, it's not easy like that, it's, okay? So this, I usually give this test question. It could be that, this, test question, test question. So make a test question, star, whatever you want, highlight, similar. Instead of -3, I will have -2 or -1 plus 2. No big deal. Questions? So we did 2 examples of it. You don't need to see more, you know. And you're going to do homework on this, okay? Okay, the next is we need to do example number 3. So what should be my example number 3? Yeah. So I have to do one problem with a horizontal shift, right? F of x, you guys give me an example now. You know how to teach now, you see? You can give me an example to write here. Tell me a basic example that you can come up with.
X minus 2. Parentheses.
X minus 2,
Parentheses.
parentheses,
Square.
Yeah, square.
square. You want to use square? Okay, good. What kind of shift is this? Horizontal shift of what? To the right with using what? X square. So now you know how, if somebody asks what kind of work or what kind of shift is this, if you just say move to the right, it's not the complete answer. You need to say horizontal shift up to the right with what? X square. F of x, y is equal to x square. Okay? So we are good with this. And we know exactly what to do. Here's our 4 points of, see, before I used to take a lot of time to graph this, right? See, now it doesn't take even 1 minute, right? And you know exactly the points. That. Which one is this? Y is x squared. This is this one. But is this one we are supposed to graph? This. So this is move to the right. Negative sign means move to the right. What is your C? 2. 2 units to the right. So take this, move to
4. Sorry. I just want to make sure that it's 2, it's not 4.
this one.
Yeah. So
This
it's
is 2.
squared. Okay.
And this is 2. This is square. 2.
Okay.
Okay, so now move 2 to the right. We have 5 points we need to work with, 5 ordered pairs. Move 2 to the right, each one. Always work with 5. This class, my direction, work with 5 points. Okay? 1, 2 to the right. This one is here. 1, 2 to the right here. 1, 2, so this end up in here. 1, 2, this end up in here. 1, 2, this end up in here. Okay? You guys see this? Okay, so we are ready. We know the pattern. Just connect the points carefully. Here's the graph we need to come up with. This is called f of x is equal to what? X minus 2 whole thing squared. We did graph this one and we are showing the graph of this is this exactly. See how easy it is? Question? Angel? Question? Follow this? Yeah? Everybody? No questions? Okay. Okay, we have to do one more example real fast. Example number 4. Who would like to give me the example number 4? Raise your hand. According to our lesson plan. Oh my gosh, I forgot your name. Gupta, your last name is Swan. Yeah, Swan.
So x plus 4 squared.
F of x is equal to x plus 4 whole thing square. Do we have the right example? Class, agree? Alright, perfect. Let's graph this one. Okay, so if I ask, let's say I'm going to ask Cindy. Cindy, right? Sarah, sorry. Sarah, can you please tell me what's your plan to graph this?
I'm going to move horizontal to the left with x squared.
Very good. You move f of x, y is equal to x squared horizontally to the left. How many units?
4.
4 units. Done. That's the solution. Okay? Alright, so let's do that. To graph this, you come up with x squared now. Same thing. X squared. Here's my x squared. So these are the 5 points. I move to the left 4 units. I'm sorry. Move to the left, yes, right? Move to the left 4 units. 4 units, yes.
Yep.
1, 2, 3, 4. So this is 1 point. Take this 4 unit. 1, 2, 3, 4. Here's the other one. Take this 4 unit. 1, 2, 2, 3, 4. Take these 4 units. 1, 2, 3, 4. Take these 4 units. 1, 2, 3, 4. If you use the graph paper, you will get this perfectly. Okay? I think it's better you graph paper to save time. Okay? So now we are graphing this. So this is the graph of what?
X plus 4 squared.
F of x is equal to x plus 4 whole thing square. You see that? Now, question. Can you graph the following? Example number 5. I did 4 examples. F of x is equal to x plus 3 absolute value. Can you graph this? F of x is equal to absolute value of x minus 2. Can you graph this?
Yes.
F of x is equal to x minus 1 absolute value. Can I graph this?
Yes.
Yes. What is this, Matthew? What is this? You said no or yes? Can you graph this?
Yeah.
Yes, right? What do you need to do to this? To graph this?
Get the absolute value.
Get the absolute value of x function and then horizontal shift or vertical shift. Is this horizontal shift or vertical shift?
Horizontal.
Horizontal shift left or to the right?
Right.
Right. You see that? The same thing. right? Can you do this? Another example. If f of x is equal to x, absolute value of x, plus 5. So I have example number 5, example number 6, example number 7, example number 8. Can you guys do this graph without my help?
Yes.
Absolutely, yes, right? You can, you know. But guys, don't take it, give lots of confidence to you, I can do this. You know, because you don't have experience here, you don't have practice. When you go home, you might forget how to do this. Now you know, you are familiar, you're seeing, you know. But when you go home, you might forget the whole thing. So you need to practice this now. You have to use your brain, think alone, use and practice this. It's like doing an exercise. You have to do it to get it. Okay? So you practice this, then you retain exactly what to do. So when the test comes, you're like this. You don't even have to think, you know how to execute. Okay? So are we good with this? Okay. Now, can I do the same thing to any of these functions? Can I put the square root function instead of absolute value of x? Can I put square root of x to this? Then you work with the square root function. Right? You see now how many graphs that you already know how to graph. There are 4 things we are going to do, left and right, up and down. But how many functions here you are going to use that 4 things to do? How many? 6. So 6 times 4 is how many graphs you are going to do? 24 graphs, already you know how to do it. Isn't that good?
Yes, very good.
You know 24 graphs to do it without thinking. But all that comes with this. You see that?
Yes.
All that 24 comes, even though you are 24, actually this 24 boils down to only 4. Right?
Yes.
This we already mastered. Question?
For example number 5, did you say that you could make it x plus 3, the absolute value, you could square it?
No, there's no square here.
Oh, I thought you said like, oh, if you square it, you should be able to do it. But I was like, that's
Oh,
too
I'm
much.
sorry. Did I say that? Sometimes, I'm sorry. If I said word square, I apologize. It's not square here. This is absolute value.
Okay.
Okay? I'm not sure. So I probably said that. Yeah. If you heard me saying, I guess I said it. Yeah. So there's no square there. Okay? You guys good with this? Okay, so, alright, so now I have to tell you guys, we are going to do other shapes, reflection, and we are going to do, but you guys are actually not doing, yeah, we are going to do, this book is calling something else here. Another thing we are going to do with transformation is we are going to compress. You're going to take x squared and compress. Okay? When you compress, what happens? If you take a wire like this and you compress, what happens to the wire now? It's open, right? It gets wide. So think of a wire that has thing and you push it all the way. So the wire gets like this, right? It's open up, right? Then another thing we are going to do is, instead of compress, we are going to stretch. So if you take a wire like this and pull there and stretch, what happens? Straight. It become what? Narrow, right? It become narrow. So it become wider. The original one can become wider and the original one can become narrow. We are going to write the rule for this next class meeting. Okay? Basically same thing like vertical shift, horizontal shift. We are going to see there's rules here. Okay? And then we are going to do a rule where the graph is rotate or graph is transformed horizontally, right? With x-axis, you transform downwards and or y-axis. We are going to do that. So don't worry about that. So there's other transformations. Now later on, after we studied all these transformations, I'm just going to give you the overall what we are looking at the next class maybe. After all, we go with like another 4 transformations. Now we are going to graph something like this. This is the major thing. So we are going to graph something like this at the end. Example, we are going to graph something like this. Y is equal to, or f of x is equal to, f of x is equal to x plus 2 whole thing squared plus 3, and there's a 2 here, something like this. Or you can have even a negative sign here. Okay, so there's this is lots of transformations here. There's an order to follow in here. Okay, so don't worry about this now. So this has vertical, this has horizontal. See, there's vertical line. So you might even have an example like this. Look at this one. X plus 2 whole thing squared minus 3. If this one has 2 transformations, right? This one has the horizontal and then vertical. So you do the parentheses first, the horizontal first. Okay? And then you do the vertical. That's what you do.
So it's just like a diagonal.
Yeah. So you take this point, move 2 to the left and 3 down. So this, instead of this point being here, now 2 to the left and then 3 down. Do you guys see that? So it's easy. We can do an example here. I don't know whether we have time. So we are going to work something like this, and then we are going to work a number here. And then it can be also a fraction here, like this, with a negative sign. You see, we are looking at more complicated problems. But to do this complicated problem, you have to be very careful with all the shifts and all the transformation, the other rules. Okay? So far today we only worked on, don't worry about this, but I'm sure you can do this one. We can do this one real fast. You can do something like this. This is what we covered today. This has both horizontal and vertical. So you take the original one. If we are graphing this, we can do it right here. Take the original one, move 2 to the left, and then move 3 to the 3 down. So 2 left, 1, 2, 3 down. So this is the vertex. Take this one, 2 left, 1, 2, 3 down. This is this. See? 2 left, this one, 2 left, 1, 2, 3 down. This is this. You see that? So the graph is like this. Okay?